quite simple. So first of all, we have fish, and when they poop, they provide ammonia for the system. And we have a pump that feeds up to another tank that contains nitrifying bacteria on hydrogen pebbles and basically break down the ammonia into nitrates and eventually nitrates.
So right now we just have small goldfish, but for the end goal of this project, we're going to have full-grown blue tilapia and a variety of full-grown fresh vegetables. And from this one system, we'll be able to produce a full-grown meal, and we're hoping to make a bunch of fish tacos.
So the beautiful part about having something like this in a class is it combines a bunch of different aspects of things that people would do in different classes. So you can see there was clearly a lot of mechanical engineering that went into building this system, what it takes to get it to circulate, using the pump, finding an energy source, some different piping that we had to do, and you might learn that in an engineering class. And then we also have to do biology and maintaining an ecosystem, which you might do in a biology class. There's just a bunch of different aspects that we really bring together instead of trying to isolate them, which doesn't really happen in the real world.
Here at North, we have a really incredible think tank, but so far most of the projects have remained within the space here. And so we wanted to create something that was very public and very visual for the whole school to see. So we found online one of the coolest projects that we've seen by a Newton North grad, Paul Friedman, out in Berkeley, California. And we followed his idea and set out to create our own innovative music tree, which would be a very dynamic and interactive project for students to participate in. So we set out to hack together some insulation foam, some basketball hoops, some solar panels, and some LEDs in order to create a space where students can sit by the tree, charge their phone, listen to some music while all learning about the environment.
Okay, so I'm doing a research on mycelium styrofoam right now, which is I'm using the roots of the mushroom to bind different media together so they form a board, and that acts like a styrofoam. The good thing about it is that it's biodegradable, so after use you can basically just throw it back to your backyard and it's going to disappear because it's just mushroom and wood and it's not going to hurt the environment.
The algae team started about 7 years ago when Greengineering first became a class, and it was sort of, at first it was just a group of kids in the old building in the basement growing tubs of algae when one of the boys came back to the class and said, let's try growing algae in order to make biodiesel. So that's how it all started. And then when our class moved to this new building and we got this new space, it sort of became the second iteration of the whole project when we started growing in more like design systems, and we started using these big 5-gallon jugs actually to grow them in much larger quantities. And then one of the points that we got to last year was we actually sent a small sample off to University of Michigan and we got biocrude back. So this is sort of the small step towards what we want to actually be a whole production chain where we can produce oils from this algae and then use it in our biodiesel.